Okay, let me just go through the responses I got. Okay. So there's someone who's saying he expect to learn more about robotics, learn something new, understand the language. I think you meant language, to master Arduino, to master materials. Materials needed, have fun using it in real life, making a living. Okay, get started. Millicent. Platform IO. Actually, we are going to touch on platform IO, Arduino IDE. Learn more about robotics. I can't seem to remember making a new skill, networking. Okay, we are going to learn all this. So let's get started. So in case you have any question, you can just raise your hand, and I'm going to allow you to unmute. Then you will just present your question. Okay. I'm opening the slides. Okay. Display capture. Just a minute. I just want to open the slides. Okay, nice. I think you can see my screen. Let me know if you can see my screen. Let me get some reactions if you can see my screen. Nice. Okay, let's get started. Number one, today in the next 2 days we are going to learn about getting started with Arduino. Actually, this meeting is made for everyone, also those who are new to Arduino and are new to maybe programming. They've never even heard about Arduino, or maybe you have some basic knowledge. You have the basic understanding of Arduino. You have ever heard about Arduino. You have ever worked with Arduino. Even to the experts, you have something you'll have to learn from this meeting. So let's get started. Okay, what is Arduino? Number one, what is Arduino? Let me get some comments there. What is Arduino in the comment section for those who have ever worked with Arduino? Actually, let me just get to know. Let me do some poll. How many have ever worked with Arduino? Either blinked LED. You can raise your hand. I just need to count. How many have ever worked with Arduino? One. How many? You can just raise your hand so that I know how I'm going to tailor my content. So we have 6. Mercy, Agnes, Caroline, Jamen, Evans Mburu, Gamba, and Paul. Okay, nice. So only 6 people have ever worked with Arduino. Okay, you can lower your hand. Okay, how many have ever heard about Arduino? How many? Okay, we get 6, 8, 9, 10, 11. Okay, nice. I have Nico. Okay, how many don't have any basic knowledge about any programming language? How many? How many don't know how to code? Don't know how to code? Only 2. We have Evans doesn't know how to code, and Jamen. Okay, only 2. Okay, so it is not a prerequisite for you to know how to code or to have any knowledge of coding, so that you can you can start tinkering with Arduino. Okay, so let's get started. If you can see my screen, type 1 on the comment section. 1 1. Okay, nice. Okay, that's nice. Okay, thank you. So let's get started. This meeting is hosted by Mr. Arduino. I'm Mr. Arduino, but my name is Fred Munya, and I'm in partnership with ALX Robotics Club. We are going to do some brief introduction to ALX at the end of the video, or at the end of this meeting. There's an official for ALX Robotics Club, actually the leader who is heading the ALX Robotics Club is going to brief us. So, if you want to join ALX Robotics Club, I'm going to send a link for you to join the ALX Robotics Club. Sorry, whereby we usually have some online meetings like this one, and also physical, all on-site meetings but all of them are usually free. So for this one, it's a 2-day online meeting, which is today and tomorrow. We are going to learn the basic of Arduino robotics, and as you can see in the poster, we get some components. We get ultrasonic sensor, and we have Arduino with which is attached to those 3 LEDs. LED stands for, let me see in the comment section. LED stands for yes, nice, Carol. Light emitting diode. I can't see your screen. Can you confirm? If you can see my screen, can you type 111? If you can see my screen, you can. I think, Carol, you have to, maybe you can leave and rejoin the meeting, because maybe it's you have a challenge with your internet connection. Okay. Let's continue. Also, that is my number. You can also follow me on TikTok at Mr. Dino for my content. I usually post my content on TikTok about robotics, and also I have a YouTube channel. You can also find the link on that TikTok account. Okay, let's get started. So today is day 1. Actually, right now it's at 8:22. We are a bit late, but day 1, our agenda is about us, introductions, actually, that we are going to do at the end of the video, at the end of this session, and disclaimer. Actually, let me just say the disclaimer right now. The disclaimer is that you don't need to have any prior knowledge of programming, of any programming language, or any knowledge about physics, and any background about physics, cells and simple circuit, but you can still learn about the same, because when we hear about robotics, we usually think robotics, you have to be you have to know all those principles of physics, and it's a good start. You can start from that, but it's not necessary. You don't need it. It's not a requirement. So next we are going to basic electricity and electronics. Maybe we can see how electricity is being produced. How do we get electricity, and so forth. What is it? What is Arduino? What is robotics? What can it do? Who cares about Arduino? Okay, then the hello world of Arduino, it's a blink. Okay, we are not going to, you can also make the disco light with it. That is the hello world of Arduino. So in any programming language, the first code is usually called what? Let me see in the comment section. Let me see in the comment section. What is the first code in any programming language? What is the, what is it? Let me check the comment section. Yes, it's usually called hello world. So if you don't understand hello world, you cannot understand anything to do with that programming language. Are we together? So now again in robotics, you have to have that basic understanding. Like in maths, 1 plus 1, you have to understand what is 1 plus 1. Pin the screen. Yeah, I think if you cannot see my screen right now, you can just pin my screen. Yeah. Also, you need to, maybe if you are using a phone, you just need to put it in landscape. Okay, for any programming language, you have to understand hello world. If you cannot understand the hello world, you cannot go anywhere. You cannot understand anything. So number one, understand hello world. But now in electronics, how do we know which is the basic most thing we need to understand so that we can start mastering robots and robotics things? Which is the code? Which is the circuit? What do we just need to master for us to be masters? So in robotics and in Arduino, it's usually called blink. Like you just need to turn on LED for 1 second and turn it off for another second. Actually, if you can do that, you can do anything with robotics, anything to do with robotics. So I think for that we can just get started. Also, we are going to learn about using variables. What are variables? And actually, variables are just like containers. They are just containers. We're going to learn about that. Maybe we are going to learn also about if statement, and we are going with if statement. We are going to read button states, either high or low. So in the world of binary, okay, we have other worlds. When we come into programming, we have different worlds. Like in binary, we only have 1 and 0. Anything is written in ones and zeros in the world of binary. So also in Arduino, in digital Arduino, it's ones and zeros. So we are going to understand what is ones and zeros. And then we are going to learn about analog sensors. Maybe we can fed LED. It's called a breathing LED. Also, we can make a sound using buzzer. Maybe make a Christmas song or something, melody. Yeah. So is there any question up to there as we continue? Any question? If you have any question, you can type there in the chat. Okay. So okay, actually, I would have just asked you Arduino board. These are just introduction. So who made Arduino? Actually, Arduino was made by several friends in Ivrea, Italy. That is in Italy. In which year? 2005. But okay, the main guys who are attributed to that innovation, they are called Massimo Banzi and David Catuelles. Hey, those two guys. But actually it was a group of people who actually they were friends and they were makers also. So before Arduino was discovered, actually before they came up with the idea of making Arduino, it was hard for anyone to be a maker and to build projects, like maybe just turning on light using okay, remotely. Let's say turning on light for like 1 second and off, or maybe for 1 minute and off for another minute. You actually initially you needed to learn about a whole course for that. But for these guys, actually they saw that loophole, and they came up with this innovation to come up with Arduino board, which will be beginner friendly, and also you will not need any prior knowledge about any PLC. Actually, we have something called PLC. If you have any background in electrical and electronics engineering, or okay, related engineering like mechanicals and so forth, you learn, I think you can understand what is PLC. PLC is programmable logic controllers. So that is another dimension of advanced, I can say in quotes, advanced Arduino. So these guys came up with Arduino Uno. Actually, they came up with Arduino board, which they made it to be open source. What do we mean by open source? Actually, open source, it's like anyone can contribute to open source. Like you can use their board. You don't need to ask them. You don't need there is no any copyright for that. You can build your solution on top of that using Arduino, their board, which is Arduino Uno. Sorry, any Arduino board. You can create your you can create your project on top of it. So Arduino is for you to code Arduino, you need to have a basic programming language. Okay, the basic knowledge in programming, but it's not necessary. But for this crash course, we are going to, because I know many of you maybe they might not have any knowledge of any programming language. So Arduino is coded in C++ and C also. We are going to see that. So this is the Arduino Uno. It's the most popular board for any beginner. So for any beginner, you can start with Arduino Uno. Don't go for any board you get, but Arduino Uno is the best fit for you. Next, we get Arduino software installation. I think this was not supposed to be here. Sorry for that. I think my sorry. It's okay. Just ignore that. It was not supposed to be there. What can it do? What can Arduino do? Arduino is great for prototyping ideas. So let's say you want to build a very great idea. You don't need to maybe venture into PLCs, which are very expensive. Let's assume even the idea will be powered by PLC or other powerful boards. You can start with Arduino. For simulation, you can just simulate and prototype. What is prototype? Prototyping is the act of making the first phase of your project and proof of concept. Before you do anything which is great, you can just prototype. You can assemble your circuit in a puff board or breadboard, and then you try out the features. If they work, you can now advance and build more advanced series of the same project. Okay, next, what else can you do? You can implement some projects like smart irrigation system, whereby, like for example, you can implement a project whereby you are using moisture sensor and Arduino, the microcontroller itself, and also a relay. If the moisture level is below 50%, you can just it will prompt the microcontroller to turn on the pump. And if the moisture level is above that, the pump will remain off. Also, other systems like cooking oil, milk ATM. Okay, we have cooking oil ATM and milk ATM. I think you have interacted with the same, and they are powered by Arduino. By the you can you can develop it. You can make it yourself. You can do it yourself. You can develop one. You can develop your own milk ATM and maybe sell. Actually, they are very expensive, but the approach is very simple. Actually, it's also an open source code. You can get it and fabricate on top of it and make sales. And street lights, actually street lights you might find they are powered by Arduino, and traffic lights because it's just actually in the at the end of this crash course we are going to maybe simulate the working of traffic lights. Also we have sorry DIY phone. You can make your own phone. I have done that before. I think if you follow me on TikTok you must have seen that. Arduino can drive motors. You can make your own electric vehicle, EV, and also I've made my own robots which are driven by Arduino, are powered by Arduino, and they have motors, electric motors which are DC as their engine. Arduino can turn on lights from anywhere in the world. By the way, let's assume you are in Canada and your light is in Kenya. You can automate that process of turning on the lights and off. Let's say you travel far from your home and you forgot to turn off your lights. You can turn it off from anywhere using your phone. In fact, using your voice commands, and you can trigger controls. Yes, what was that? Any issue? Oh, my TikTok account, it's just a minute. Let me send. So this is the link to my TikTok account. You can also follow me there. Okay, let's continue. You can build autonomous project or any automation project using Arduino. Very simple. You're going to see some of my projects there. Also, you can power your. It can be a power. It can power your final year project. Actually, many final year projects in universities and colleges are usually powered by Arduino Uno. And for that, if you have your final year project and you don't know anything to do with it, and it's under the category of electrical and electronics and computer science, any IT related agriculture, I can help you to implement it. So my number is on the poster. So next, who cares about Arduino? Hackers. Actually, I wanted to become a hacker when I was young, but now I'm a maker. Actually, hackers and makers usually use Arduino to do some attacks. I've done several before, but actually those were not ethical hacking. But for me, I'm ethical hacker. So using Arduino, you can rely on certain Arduino boards. Like I'm going to mention few of them. You can use Arduino Pro Micro, not Arduino Pro Mini. We have actually another dimension of microcontrollers like a Raspberry Pi. So if you are here and you were in my last Raspberry Pi class, can you raise your hand? Let me see my legit people. Evans, I can remember you. Even there was another person I can't remember. Yes, Paul, I can remember you well. So, okay, that's okay. So, you can also use the Raspberry Pi as a rubber ducky. I think you know rubber ducky, and maybe still some. Okay, that is not ethical. Let me get out of that. And engineers, if you are an engineer, you can use Arduino to prototype your idea before you make it the final one. Also, maybe in the future sessions, I'm going to show you how you can build your own Arduino board from scratch. With few components, you can build your own. Instead of buying one, you can build your own. So, artists also, you can use Arduino. Musicians, you can build some consoles like drums kit. Actually, I have a project which I did about DIY drums kit. So if your church or if your band doesn't have any drums, you can opt for DIY drums kit, or maybe you can contact me. I can make one for you, very cheap. Okay, kids, actually you can use Arduino. Actually, you can use Arduino with Scratch. So for kids, you can code in Scratch. Scratch, some people usually say Scratch is a programming language, but it's not. Okay, the same way people say HTML, CSS, and okay, HTML and CSS are programming languages, but they are not. Okay, it depends. Teachers, I'm a teacher. Maybe I'm a teacher. I usually teach Arduino robotics to primary, high school, even universities. We usually use Arduino. And you also, if you are in this call, you can use Arduino. I know you're going to learn some interesting things about Arduino, and I'm sure you're going to use Arduino. Okay, any question as we continue? Any question? Any question? Okay, let's continue. Arduino family. So in Arduino family, we have over, I can say it's over 500, if not over 1,000 boards actually. But for me, I don't know all of them, but I've worked at least with over 20 Arduino boards, of which even ESP is under Arduino. Okay, it's under advanced Arduino boards, but it's okay. So in this slide, I'm going just to touch about several of them. Actually, number one, it's called board Arduino. I've never worked with this one, but it's very simple. Actually, I can make my own board Arduino from the word board and Arduino. It's a Arduino because it's as you can see in the slide, it has only, I can say it's a standalone system because it has the Atmega 320p and 16 megahertz crystal oscillator and 22 picofarad capacitor, two of them, and you can see even we have 10k home resistor. Next, we have Arduino LilyPad. So let's assume you want to build a project which is a wearable project, and you want maybe to attach to your jumper or to your cloth. You can use LilyPad. It has several features, like you can see it has so many I/O pins, which are digital input output pins. So you can go for that. And also it's very small. Actually, if you want to build your own smartwatch, as you can see the shape of LilyPad, it's like a smartwatch. Maybe it resembles one, so it can power one. Okay, the most popular Arduino board, it's called Arduino Uno. As you can see in the middle, the Arduino Uno, it has several features I'm going to show you. We are going to discuss more about it. So if you're a beginner, you can start with Arduino Uno. Actually, I started with Arduino Uno, and also you can. Also, we have DIY Arduino. That is the board which I was telling you. Actually, it's like basically it's Arduino Uno DIY, which you have done it yourself. You can see it has 22 picofarad capacitor, two of them, and it has 16 megahertz crystal oscillator. So don't worry if you don't understand what I'm talking about, but as we get on, we are going to understand more. Also, we have Arduino Mega. Actually, Arduino Mega is an extended Arduino Uno. As you can see, half of it resembles Arduino Uno, but the other quarter you can get its extended one. It has several pins. You can see it is extended pins. Actually, it has around 54 digital input output pins. Unlike Arduino, it has only 14. You can see if you are building a huge project, let's say it's a robot which it's using different components and sensors, several of them, which are maybe many of them. You can opt for Arduino Mega instead of using Arduino Uno. So if you have any question, you can interrupt me by raising your hand, because I'm going to answer your question. Does Arduino has challenges with cyber attack if we are remote? Can you paraphrase your question? I think I cannot understand your question. Paris, kindly. Maybe you can rewrite your question well. Okay, let's continue. Arduino Uno specification. So before you work with any project, you have to understand the specifications of that project. Specification of that board, or any electronic component you want to work with. Be it a resistor, you can download the data sheet. Actually, before I work with any component, I have to understand into deep what is the operating specifications of these components which I'm using. What is the working principle of it, and I have to understand it well before even I use it. So what is the, like for beginners, I'm wishing you to start with Arduino Uno. So what is the specification of Arduino Uno? What does it have? Number one, it has 14 digital input output pins, whereby 6 can be used as PWM. What is PWM? Can you comment there below? Okay, we are going to see that. We are going to see the 14 digital input output pins. Okay, next it has 6 analog inputs. Actually, these analog inputs, you can hack them to be output pins also, but you need to know how to code well. It has a USB. Actually, it's one USB connection. The USB connection can be used for programming the Arduino Uno board. It has a power jack for powering the Arduino. It has a reset button. A reset button is used to reset the code back to the default. Actually, if you press the reset button, the code will start from beginning, which is void setup. Onboard LED, which is connected to pin number 13. It has SCL and SDA pins, which are serial clock and serial data pins. So if they are used for communication, and if you are using something like LCD and any other communication, maybe you're communicating between the Arduino and another Arduino, you can use I2C communication via those two pins, which are by default they are SDA. It's at pin number A4, analog pin 4, and SCL it's at pin analog A5. In short, it contains everything needed to support the microcontroller. Simply connect it to a computer with a USB cable, or power it with an AC to DC adapter or battery to get started. Okay, let me see any pulse width modulation. Paris was asking if a remote project is. Can I get the question really correct? Okay. Does Arduino has challenges with cyber attack if a remote project is implemented? So yeah, actually it depends with your coding and maybe the vulnerabilities of your system. But actually Arduino it's a low okay, it's a, I can say it's actually it's usually called a poor man's rubber ducky. If you search you Google poor man's rubber ducky, you are going to get some Arduino rubber duckies. You can use them to exploit some. Okay, I'm not going into details about that, because that is another approach for cyber security. Okay, I think Emmanuel Kivuva was asking about pulse width modulation. What is okay? Okay, we are going to talk more about pulse width modulation. Okay, as you can see, what I was explaining is there. Digital I/O pins, PWM, is pin number 3. You can see the pins with that icon, the wavy. It's called wavy hyphen. Pin number 3, pin number 5, from the Arduino board itself, whereby we have digital pins. Okay, pin number 3, pin number 5, pin number 6, pin number 9, pin number 10, pin number 11, they are PWMs, which mean pulse width modulation. Actually, these are pins which act as analog pins, but yet they are digital pins. Okay, we are going to learn more about. Actually, they are abnormal pins. You can exploit them to get some maybe to fed LED. Actually, I told you digital, it's only high and low, on and off, 1 and 0. But with these pins, they act abnormally because they can give us uh, another value rather than 1 and 0. We are going to see that. Okay, the pinout diagram. This is the pinout diagram. You have to understand well the pinout diagram of Arduino Uno and or any board you are working with. At number 6, okay, from far left, we get PC6. It's a reset button. So if you connect the reset button to, you showed the reset button to ground, you're going to reset the button, to reset the board. You're going to reset the board, and after that we have the power pins. It's a okay, Arduino Uno board. It's a 5 volts tolerant, 5 volts tolerant. So if you have 5 volts, you can power the Arduino Uno with 5 volts, and the outputs will also be 5 volts. Just a minute. Okay, let's continue. The outputs between 0 and 1, if the digital pin is going to send about, it's going to be addressed at 1, that means it will produce 5 volts. Then at 0, it will produce 0 volts. Okay, next we have 5 volts. These are just power pins. By default, they are supplying constantly 5 volts. And ground, GND, stands for ground. Ground is usually the negative. So in DC, we have negative and positive. So here we have ground and VCC. Okay, so Arduino has 3 grounds which are internally connected. So if you use one ground, it's the same as using the other. Okay, and it has V in, which is a voltage input pin. So if you are powering the Arduino Uno with the external voltage, you can opt to use that V in pin. Okay, next we have the analog pins. You can see the analog pins. I think you can. The analog input, they are input pins, but also by default they are input, but also you can hack them to the output pin. As you can see in pin number A4 and A5, we get SDA and SCL. Those are I2C communication pins. Okay. The other part, actually these are outdated Arduino, but also it's still in the market. We have other newer versions of Arduino, and good news is that you can also make your own Arduino board. By the way, you can also make your own clone and maybe sell, and even sell it without even any seeking for any copyright or license, actually, because it's open source, it's free. Okay, tabulated specifications. We had the microcontroller which is using. You can see the black IC integrated circuit from on the Arduino Arduino Uno image. It's at Mega 328PU. That is the microcontroller or the IC. That is the brain of the Arduino Uno. Operating voltage, it is operating at 5 volts, unlike Raspberry Pi, which we saw. Raspberry Pi operates at 3.3 volts or maybe 3 volts actually, and the input which is recommended, it's 7 to 12 volts. But okay, Arduino, we have three ways we can power Arduino Uno board specifically. You can power Arduino Uno board with power jack. Actually, the power jack it can support up to 20 volts DC, 20 volts DC, and via the USB port, you can also USB ports has two functions. It can power the Arduino Uno, and also you can program it using the USB port. But strictly, you must supply up to 5 volts. DC. Okay, we have AC and DC. I'm not going to that because we covered that in our previous meetings. Okay, so you must power with at least 5 volts and at most 5 volts DC. And also for the V in and ground, for the V in pin, you can only power it with 7 to around 12 volts. Yes. Okay, let's continue. Okay, as you can see, the limit is at 20 volts, 6 to 20 volts. And also the digital I/O pins, we have 14 of them. 6 of them are PWM output. Okay, it has 6 PWM input output pins. It has analog pins which are 6 in total, and it has a DC current per I/O. Okay, it's 20. Okay, this means the board can only supply a maximum of 20 milliamperes in just a minute. Let me look for the charger. Is there any question? Maybe I can be answering the question. Okay, I can get one question here from Deuri Moniki. He's asking, are the pins named on the board? Yes, sure. As you can see in the in that diagram, the pins are also named, or okay, it's called labeling. They are also labeled on the actual Arduino board. But you need to understand more about the pin numbering, because we have other pins which are also named. But okay, you need to understand more about the pins. Okay, next, is there any other question? Okay, there's no any question. Let's continue. Okay. Home. Okay, the DC current for 3.3 volts pins is at 50 milliamperes. That is the maximum current it can provide. That's why I usually tell you, never connect any motor directly to the Arduino board, because motors usually draw a lot of current, and it will burn your Arduino board. It will spoil the Arduino board. So rather, you just need to connect via a MOSFET, or maybe a transistor, or a motor driver. Okay, next, what else we need to so for the 3.3, it will provide around 50 milliamperes. Then the flash memory of the at Mega 328P, it's at 32 KB, of which 0.5 KB is used by the bootloader. Okay, we are not going to much details for that, because that is a bit more advanced. It has a static RAM of 2 KB. It has a EEPROM. What is EEPROM? EEPROM is a I think it's electrically erasable, programmable, read-only memory. Okay, these are memory whereby you just need to, let's assume if you put any data to the EEPROM, even after reboot or restart, you will still find the data. That is the simplest explanation I can give. It has the clock speed. It's at 16 megahertz. That is the frequency, by the clock speed. That is the speed, and we're going to see that it's at 16 megahertz. LED built-in. It's connected to pin number 13. Okay, as you can see in the, if you can keenly look at the diagram, you can see a part labeled L, which is near pin number 13. So that L, it's a means light LED. Okay, so if you don't have a physical LED, you can just try to tinker around with that, and it's internally connected to pin number 13. Length 68.6 millimeter. Width, it's 53.4. Actually, these details are good, are important if you are trying to design a PCB, or maybe you are trying to make a casing. So you need to get the length and width. So download. So number one, you need to download to download the Arduino IDE. Let me look for that. Yeah, software installation. Arduino software installation. Why Arduino? Okay, Arduino is open source. It's free, available online with resources at www.arduino.cc. Actually, from there you're going to get a lot of information about Arduino, the forum. You're going to get to download the Arduino IDE and so forth. So it is easy to get started. That's why you are here. Very large community, actually, very large community of makers. You too, you are going to be contributors to that community, ushering entry into robotics and your robotics dream. So if you have a dream to become a robotics trainer, a robotics and like a robotics maker, you just need to start from Arduino. Yes. So let's continue. Yes. You have to download the Arduino. It's free, but you can donate. You can donate. By the way, there's that field. If you have money, I usually donate me. You can donate. It's available for all operating systems. I think I meant to mean that all operating system, Mac, Windows, and Linux. So also for Android. By the way, you can code, but it's not recommended. I remember there's a time I used to code Arduino using my Android. It's free. Don't forget to also download. As you are downloading the Arduino IDE, you will be prompted to download the drivers, the supporting drivers, which are okay. There are several of them, but in case you accidentally click on cancel, you just need to install the CH340 drivers. These are drivers which are responsible for accessing the components, which are the ports of your machine, either laptop or your computer. Okay, this is the IDE. Under the IDE, we get the. Am I going so fast? Are we together? Can you type one if we are together? One, one. I just need around 10, one. Yes, one. Any question? What is IDE? What is IDE? Let me get what is IDE. Someone should unmute. Let me even, I need to hear your voices. What is IDE? What is IDE? Someone, you can unmute and just say what is IDE. Someone unmute.
Integrated development environment.
Oh, nice. Who was that? Oh, nice. Okay. It's true. Millicent also. Integrated development environment. Okay, list several types of LED. Sorry, several types of IDEs. You can list there on the comment section.
VS Code.
Yes, we get. I can get Millicent Anaconda, VS Code, VS Code, Joy, Bevon also, VS Code, PyCharm. Actually, PyCharm you can use it for Python. Sublime, Dhoni. Nice. Samuel, you must have attended my previous meeting, online session for Raspberry Pi, because we used Dhoni. NetBeans, actually, I remember there's a time I used to code in C Sharp, and I think I used NetBeans, if I cannot, I can remember. Eclipse, NetBeans. No one is mentioning about Visual Studio. You know, we have VS Code and Visual Studio. Maybe Okay, maybe if you don't know, also we have Arduino IDE. No one is mentioning Arduino IntelliJ. Yes, Notepad plus plus. No one mentioned Notepad plus plus. Okay, 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 nice. Okay, okay. Let me get some feedback from you. You remember? Just a minute. Just a minute. Okay, okay. Let me get some responses there. Let me get your feedback. You can join. The link is pinned. You can join, or maybe you. Okay, you just need to open a new window, or sorry, new tab. Then type that code at menti.com. Yes. The meeting so far is informative. What else? Informative. Again. Well, lazima wewe ni wageto. What else? How is the meeting so far? How is the session so far? Because we are entering into another session. So, nice, 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 nice. Okay, 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 okay. Should we continue? Interesting, eye-opening. Okay. Two more. Two more. You just need to click on that link. It's pinned, or maybe you can head to menti.com and type that. Okay, okay. Let's continue. Okay, so you just need to understand the IDE the way you understood VS Code or any IDE. So if you are a beginner, never worry. We are together in this journey. You just need to understand what is verify, what is upload, what is save, open, new. So if you know how to use MS Word or any Microsoft program, computer program, you're good to go. Because after writing your code, you just need to click on verify to check for any possible errors in your code. So you must know that if your code has any errors, it will never run. It will not run. Okay? It will not run. Next, to upload your code to the board, you just need to click on upload. To open a new blank window of the IDE, you just need to click on new. Actually, all these you can use some keyboard shortcuts like Control plus N. For verification, it's Control plus R. For uploading, it's Control plus U. For saving, it's Control Shift S, save as. But if it's save, it's Control plus S. For opening, it's Control plus O. But for you to open, you need to open an existing code in your file explorer or in your storage. Okay, we have serial monitor. Serial monitor is usually used for debugging. As you saw in our case, we use in the last session we used Thorny, so we were using shell, the shell of the Thorny. It's another version of serial monitor. Actually, we also have serial plotter. Is for plotting now the reading of maybe from the sensor. Okay, we have status window, and under the status window you can see there's one. Can you see one? If you can see one, type one. If you can see one, type one. Let me see. If you can see one, type one. Okay, so one here in this case, one is the current line number. As you can see, the cursor is at line 1. It will show us the current line number. Okay, I think we have no question. Let's continue. Okay, for you to set up the board type, you just need to go to head to Tools, Board, under Boards. So I told you Arduino we have so many Arduino boards, and you need to select your own. Like as you can see in the screenshot, I'm using a LilyPad Arduino W. But at number 3 we get Arduino Uno. We have other types of boards like at Tiny 85. Also, if you want to maybe use Arduino for hacking, you can try at Tiny 85. Okay, we have Arduino Mega, several of them, even Arduino Leonardo. Okay, next we need to set up the serial COM port. This is the port, the port we have connected our hardware to, our board to. So you just need to head to Tools, then Serial Port, and select the one. Actually, it's nowadays it's under, like, let's assume we have connected our Arduino board to COM number 21. So actually nowadays it's usually displays at COM21 into brackets Arduino Uno, or the name of the board you are using. Okay, also now I know several of you might be using Linux or Mac OS. It will come with this format, dev tt dot blah blah blah. Okay, but for Windows you can always confirm the COM port from the device manager. Next are other IDEs. These are other IDEs apart from Arduino IDE. Arduino microcontrollers can be programmed using the following IDEs. IDE, we said it's a integrated development environment. So you can use Visual Studio, you can use Visual Studio Code, you can use Platform IO, you can use Atom IDE, integrated development environment, and Sony IDE. Actually, I've used all of them. I think I've used all of these IDE. So if you know any other IDE I'm leaving out, you can type there below on the comment section. Let me see any else which I'm leaving behind. None. Okay, why should you choose what choice have you chosen? Why should you choose your choice, that choice? Why should you choose that? Okay, why should you choose Arduino IDE instead of choosing Visual Studio? Why? I think that one is left for you to answer. But for beginner, it will depend. If you're a beginner, you don't need to start trying out Platform IO, Atom IDE. You can just try to think around with Arduino IDE. Okay, next analog and digital. So you must understand the basics. These are just basics. I think in Form 1, computer studies, KLB, page number 34, we learned about analog and digital signals, whereby we learned what is the difference between analog and digital. Okay, we are not going to that. All Arduino signals are either analog or digital, nothing else. In this world of robotics and Arduino, we have only analog and digital. Next, all computers including Arduino, actually microcontrollers, only understand digital. All computers, your computer only understands digital. You remember like the TV signals where we are transferred to digital. Actually, I think it was in 2013, if I'm not wrong, 2012, 2013. There. So right now we are using digital signals, and if you are using analog signal, you have a long way to go. Also, we have other ADC, which are analog to digital converters. You can use that. And it's important to understand the difference between analog and digital signals, since analog signals require an analog to digital conversion, ADC. I mentioned that earlier. Next, input versus output. Everything is referred from the perspective of the microcontroller. So, okay, we have input and output. Input, I think you from computer studies, you or from your knowledge from computer, you understand what is input and what is output. Input, like your computer has input devices, which are, can you name them there in the comment section? What are the input devices in computer? Mouse, keyboard. Which other? What else? Keyboard. What else? We have mouse, keyboard, stylus, joystick. Nice. Hey, I have bright students. Keyboard, flash. Yeah, actually, yes. Flash drives, input, pen, stylus. There's one you are missing. Which other? Trackball, touch. Nice, Samuel. I was looking for this one. Actually, it's touch screen. Screen will also. It's, if you touch it, it's input. If you just look at it, it's just output. Okay, it's a two-way. Which are touchpad. Touchpad also like acts like a mouse. What else? There's one I'm using right now. Even you can. There's one I'm using. No one has mentioned it. What is that? Microphone. Nice. Samuel Wanaina. Okay, yes. Even camera, webcam, it's an input device. Okay, what about output? Let me get output. What is output? Monitor. LED. Nice. Speaker. What else? Output. Do you have any other output? Printer, it's an output. Sure. Camera, no. Camera is not an output. Camera, we said it's input. If I open my camera, you're going to see me. So you can see me. So this is an input device. Because it's inputting the camera feed to my computer and to Google Meet. You can see me. So projector, output, sure. Projector is an output device. What else? I think output they are not that much. And plotter, sure. Yes, that was me. Back to business. Okay, next, let's continue. If you have any question, you can ask. Okay, let's continue. Actually, in Form 1, I think you saw something like this one. Analog microcontrollers use a digital on-off. Those are digital signals. But I think for analog, I'm not a good drawer. Actually, it's not me. It's not me who drew that line. It should not be like that one. The one for physics in waves 2. Was it in waves 2? Yeah, waves 2 form 3, page 112, physics scale B, book 3. So let's continue. So in digital, as you can see in digital, 0 will give us 0 volts, 1 will give us 5 volts, low will give us 0 volts, high will give us 5 volts. Hence the LED will be on. Low LED will get only 0 volts. The LED will be off. Next, analog versus digital. Microphone is these are analog sensors. Okay, in robotics, we have only three major dimensions. We have sensors, actuators, microcontroller. Only that. The others are just by the way. So under analog sensors, we have a microphone, because if I lower my tone or my voice, you are not going to hear me well. But if I increase my volume or my voice, you're going to hear me. So that is an analog sensor microphone. And we have a photoresistor, the one which is used by the street lights. We have a potentiometer, the ones for the radius, increasing and reducing the volume of your radio. Okay, we have temperature sensor, we have flex sensor, accelerometer. I'm not going to details variables. So the mic will it's going to vary sound volume. Photoresistor, light level. Sorry, light level. Potentiometer is going to dial position. Okay, it's a variable resistor. Okay, let's continue. And we have digital sensors, which are under digital sensors we have they are just straightforward. Unlike for analog, they just give us 1 or 0. Like for example, a push button, a switch. The switch you are using in your house, it's a digital sensor. Actually, it's a sensor and a push button. Okay, what programming language do we need to understand? Or rather, what programming language is used by Arduino boards? So Arduino boards are programmed using Arduino programming language. Nice. Actually, many people get it wrong from this point. Listen, Arduino boards are programmed using Arduino programming language. Who said Arduino boards are programmed using C and C++? Arduino boards are not programmed using C and C++, but they are programmed using uh, Arduino programming languages. Okay. Okay. Any question? Yes. Actually, I get a comment from Samuel Waithaka. Yes, it's a modified C stroke C++, but it's not C and C++. So, like, let me say, let's assume, okay, let me not use that example, but I can be, what should I say? You can be product of two occurrences or two variables. Like say, let's say your mother and your father are not from same tribe. So, but now you. Am I making sense? So your Meshach, your father is C and your mother is C++, and you are Arduino. So C, the combination of C and C++ now will give you to will bring you to Arduino. I think you can understand. It's modified. Actually, it's modified C and C++ Arduino programming. Because why am I saying Arduino and Arduino is not C and C++? Because all programming languages have same structure but different syntax. The syntax you are using for C, actually they are not the same as the syntax you are using for C++, and also they are not the same as you are using for Arduino. Actually, the way you write your code in Hello World code in C is not the same way you write in C++, and it's not actually even Arduino doesn't have a Hello World. So let's continue. Okay, advanced user. So Arduino programming language is made up of C and C++ programming languages. I think I've done that. I've made that clear. Advanced users using advanced boards can program them using MicroPython and CircuitPython. I think we did that in the last class or our past sessions, but we are going to do that more in our future sessions. So we have a question here. Do I need to learn C and C++ to start prototyping in Arduino? you need to learn C and C++ to start prototyping in Arduino? Comment there below. I think that one also is left for you to answer. If you cannot get the answer, you can you can ask me at the end of this session. Any question? Let me check the chat. No question. Let's proceed. A valid Arduino sketch has okay, actually it has a setup and a loop. Actually, they avoid setup and void loop. Any Arduino code, any valid, you can have a Arduino code which is not valid. Okay, let me say any valid Arduino sketch, actually they are called sketches, all code must have void setup or void loop, and must have void setup and void loop function. The void setup function runs only once at the start of the program. Actually, it's used for initializing the board and maybe the environment, any inputs you are using, any outputs, and maybe okay. And the void loop is used. Any code you put in the void loop will run repeatedly forever, to repeat itself forever. Okay, we're going to see that. You can upload your sketch to the Arduino board using the IDE. I think we have covered that before. Yes. In case you have any question, you just need to raise your hand. Okay, the 6 major concepts which you just need to understand as a beginner. You need to understand what is digital, right? What is analog, right? What is digital read? What is also we have analog. Okay, it's there below. You need to understand if statements, that is Boolean, true, false. You also need to understand analog read. Okay, and the serial communication, like serial dot print or the serial the board. Okay, that is for serial monitor. Next, you need to understand serial communication. It's called serial because data is broken into bits, each sent one after another in a single wire. Okay, compiling. Okay, we are not going to touch much details. Okay, but let's say you want to debug. You have made a smart system like a home automation system, which will turn on lights if you send a voice command like turn on the kitchen light. And maybe in operation or in production, if you say for instance you say turn on the kitchen light, maybe it doesn't turn on. You just need to debug. You just need to open the serial monitor and see up to what instance is your project or it's your code not running, or what might be the issue. Okay, also for the serial communication, it's usually usually happens through RX and TX. RX is the receiver and TX is the transmitter. Also, you can RX by default. RX is the RX is usually the pin number 0, IO. Sorry, the digital pin 0, and TX is usually pin number 1 by default. But also you can define your own. But now, okay, they must be PWM, pulse width modulation enabled. But also you need a software. Okay, you need a library for that, which is usually called software serial or serial software. Yeah, it's called serial software. Okay, this is the basic program for Arduino. So for any beginner, you need to understand this basic code. So actually, it's called Hello World in a layman's language. Okay, so for a beginner, it's a must. You must start from this one. You must understand this one. So let's rush through it. So basically, this is the structure of Arduino program. Actually, you can see if you open a new sketch, you are going to get the screen you are seeing. And in fact, these are code which is valid. In fact, you can, without making even any changes, you can just upload the code as it is. Yeah, because it meets the minimum what is it called, minimum threshold, or minimum requirements, because it has the function for void setup and void loop. But it will not do anything, you will not achieve anything with it unless you now fabricate more code into it. Okay, in case of any question, you can raise your hand. Okay, this button, after writing the code, you need to upload. If you click this button, it will first verify your code to check for any possible errors, as we did in Raspberry Pi in Dhoni IDE. So if your code it has any error, even a single one, it will never upload to your board. Let's say you omit a semicolon, maybe a syntax, or syntax error. You know, we have two types of errors, which I know. Maybe there are some others, but we have logic and I think it's logic and syntax. Yeah. Okay. Cool. So are you ready? Can we start coding, or we are out of time? Let me see. Okay. Okay. Also, you can join. Okay. Again, you can. I need your input. The link. Can we start coding? Are you ready? If I get five responses, we are going to continue. Are you ready? Yes. Next. At least 5. That's one. Oh, don't like. Type yes or no, or we are out of time. Maybe we can write our first code. Let me get your response. Okay. Maybe you might not. We can too. How do you participate? You need to just scan. The link is attached. It's pinned. Someone can send the link. Kindly, someone can resend the link. If you get the link, you got the link, you can copy paste there. I get 3, 1, 2 to go. Two more. 1. Yes, it's, I think this is the same person. This might be one person. Okay, it's okay. Okay, let's continue. Okay, just a few minutes, then we're going to. Okay, let's start coding. We're going to get your hands dirty with code. Okay, project number 1. It's called, I told you, Blink. It's the hello world of the physical computing. Actually, hello world of the physical computing. Okay, as you can see below, this is just an overview of what we are going to do. we're going to turn on LED, we're going to wait, turn the LED off, wait, and rinse and repeat. We are going to repeat the same over and over. Okay, next. Okay, these are 3 commands to know. Actually, you can master these ones. We have pin mode. Pin mode, you have to declare the pin, either input or output. Example, pin mode, pin 13. This is the port or the pin of the Arduino board which we have connected our device. Then the output is the mode. You understand? Is the mode, either input or output. Okay, so if it's an output device like LED, like speaker, the ones you mentioned, screen, that will be output. If it's an input like sensor, ultrasonic sensor, a push button, a switch, what else, any sensor, temperature sensor, it will be an input. Okay, then we have digital write. You must understand these keywords. Digital write, then we are going to say pin, and also we are going to define it as input or output. We only have these 2 variations, either high or low. So if it's high, that pin, for instance, it's pin number 13, will send 5 volts to it. If it's low, it will only send 0 volts and the LED will be off. Example, digital write, pin number 13, high. So from this example, the LED will be on. Okay, if we replace the high with low, the LED will turn off. Delay, actually delay, it's given by default, is given in milliseconds. And okay, we are going to see that. So these are, let's continue. Any question up to there? Any question? Okay, output is always digital. Okay. Any question? Okay, now we are going to learn about using variables. Variables are just like containers. Just like containers. I think if you have any knowledge of any programming language, you must understand what is variables. But if you don't worry. We can relate placeholders in the code. So in the example, you can see we are going to define int LED pin and assign it to that LED pin. It's a variable. We're going to assign it to pin number 3. Understand now? So whereby we are going to connect pin number 3 to the LED, the positive of the LED. Then after there, we're going to enter into the function of void setup, whereby we are just going to set our environment and define and say pin mode, LED pin, we give it to the mode of output because we are going to get light from it. It's an output device. Then void loop, and a void loop, in this code, we just need to turn on the LED. Just that, turn on the LED. Okay. Variables allow you to store. I think that was not supposed to come to this because we just need to code. Are you ready? We can maybe you can write one code and call it a day. Yeah. So okay, we have 2 options. Let me see if we can we can use a online simulator, or maybe we can use physical components. I have physical components, but also we can use online like Tinkercad. We can use Tinkercad. So which one do you want us to use? So let me give you a is there any question? Okay, let me get the votes. Which one do you want us to use? Should we use online? Only one, three, online. Okay, because you are still online. Okay, online. So we should use online compiler. Okay, sawa. So I think I need to okay, I think you can see my screen well. Nice. Okay, let's continue. So head to Tinkercad, but msizoe kutumia online, it's not good. It's good still, but I think you need to, because it's robotics and it's hardware, you need to purchase the components. And also I can tell you where you can buy the components at a cheaper price. So the shop is called okay, let me it's called Blue Pack Nova. You can purchase the components from this shop. Actually, it's very cheap. I usually purchase my components from this shop. And there's a project I'm working on, and if you look closely, watch my TikTok videos, you are going to see that robot I'm building. I purchased the components from this site. Okay, as it's loading, let's continue to with Tinkercad. Actually, in Tinkercad, you can do a lot. You can design your 3D models and even print them. But now we are interested in Arduino tinkering. Actually, I have an account. Let me try to log in. I log in. Educator. I think educator. Let me hide my credentials. Where is just a minute? You don't need to see this. I think Raspberry Pi. Okay, let me let me log in. Any question? Let me see. Walkway. Yeah, you cannot. Oh, you want us to use Walkway? By the way, we can use Walkway. Actually, Walkway is best. Is the best, by the way. I think you cannot see my screen. Okay, yeah. I'm trying to Walkway. Walkway is light. I like. Actually, let's use Walkway instead of okay. You can use either Tinkercad or Walkway, but let me see votes. Can you vote on the comment section? Walkway 1, Tinkercad 2. Type for Walkway it's 1, Tinkercad 2. Type 2. If you want us to use Tinkercad, type 2. For Walkway, type 1. Let me get the polls. 26. Well, Caroline, it's either 2 or 1. We are in binary world. Okay, let me see. For Walkway two one. Okay, let's use 2 was Tinkercad. Okay, let's use Tinkercad. This is Tinkercad. Okay, this is my name. For your information, these are some of my past designs. Okay, we can design one. Okay, I think you need to go to create. I normally don't like using an online simulator because I have the physical devices with me, but if you don't have the budget, you can opt for this one. Why not? Okay, let me close these ones. I'm going to send this link to Wokui. I said you type one. You failed the exam. You failed the tests. So you have to type one, not Wokui. Okay, so Arduino. Okay, you need to the components which you're going to use. You just need to prepare them and to drag them to this working area. I think you can see my screen. Okay, nice. So I need to drag Arduino Uno. If you are using Arduino Mega, I don't know if they can provide Mega. Okay, they don't. But for work with, I think if you are using Arduino 80Tiny, you can still use that. Okay, for Arduino, we are going to use this Arduino. Yes, this way. Then you can even change the name. You say this I'm using it's Arduino. Okay. Next, we need to look for LED light dependent resistor, light emitting diode. So this LED, red LED. You can even change the color. I think there's a way you can change the color, but we are not going to that. Also, you can use a breadboard, but we are not going to use that. Next, we need a resistor. Never connect LED without a resistor. So also you need to understand the type of resistor you are using. So you can use 220 and 330. So if you use like a 100 kilo ohm resistor, it's not going to light because they resist a lot of current, so no current will be reaching the LED. Okay, any question? Let me see. Any question? Are we together? Okay, so don't worry, I'm going to upload this video. You can follow. Let's just do the light the LED. You can follow on with the tutorial. I'm going to post it on YouTube, so don't worry if I'm fast. But you can always ask a question. You just need to raise your hand. So okay, this is the negative. The negative is aka cathode according to chemistry form 2 chapter 2 page 17, and anode, this is the positive. So the anode is usually connected to the digital pin because you are going to get either 0 or 5 either 0 or 1, and 0 is 0 volts and 1 is 5 volts. So we just need to connect to the sorry to the digital pin. Okay, so let's do that. Okay, the cathode is always connected to the ground. Actually the cathode is the negative, so we connect the cathode to the ground, direct to the ground there. Nice. And it's a best practice to put the cathode to be black. Color coding, you understand color coding from physics. Okay, we are going to connect the anode to pin 13 but through a resistor. So for that we just need to do this. But okay, color coding for this one should be red. So the positive is usually, but doesn't matter, but it's a best practice. So to pin that in. Okay, also let's assume you don't have the LED. You can still write your code and test it via this inbuilt LED, which is usually connected to digital pin 13. Our circuit is complete, by the way. You can go to code. In case of any question, you can just interrupt me. Okay, the best thing, if you are a kid or you have a kid, they don't need to understand C++ and C. They can write in, they can code in block. Actually, you can get this code, it's written here. So you just need to drag and drop. You can, but for me, I'm a grown up, so I don't need to do this. So I just need to look for text based, this code. Okay, actually the code is written for us. We can just upload and see what will happen. So we just need to click on start simulation and check. I think you can see the LEDs. Sorry, the LED is blinking. Okay, let me get some reactions. Hey, nice. Reactions. Wow. Thank you. So I think right now you have written your own. You can okay, but we can write. Let me explain the code, how the code works, because this code was written. It was there. So okay, these are called comments. So any text after double forward, what are they called? Forward slashes. It's a comment. The compiler will ignore it. Okay. So this is not part of the code. Next, we have void setup and void loop. As you can see, we say this is a minimum reducible minimum. You must indicate in your code for it to be valid. So we are going to say pin mode LED. Okay, built-in LED. It's the built-in LED, which is pin 13. It's aka built-in LED. We are going to set it in this mode output. If it will be an input device like sensor, we could just say input. Okay, but it's an output device, okay, or components. Then we are under void loop. So we said any code we put in void setup will not repeat itself, because like we just need to say, like for example, the way I told you my name, I never repeated my name again throughout this call. But so for this one, we just need to tell the LED you will be output. We need to tell the microcontroller we have connected LED, which is an output device, to pin number 13. Okay, then digital write, we are going to write LED built-in high. We'll turn it on. In this line, the LED turns on. The LED turns on. Then here, under delay, it will wait for 1 second. Actually, the delay is usually given in milliseconds. 1 second is equal to 1,000 milliseconds. Then we are going to tell the LED turn off, because we are going to tell it to low. So the LED turns off. Okay, and waits for 1,000 milliseconds, which is equivalent to 1 second. Okay. Then this code, after this line, it will jump back to this line, then this line. You remember with the case of Raspberry Pi Pico, then next, then back to line number 1, 2, 3, 4. So it will loop itself forever. Any question? Oh, nice. This is a nice question. I was waiting for this question actually. The pin you have used is 13. Can you use the rest of other pins? Yes. Okay. It's a valid question still, but there's another question I was looking for. Someone would ask me, why have you written LED built in instead of writing pin 13? Any answer for that? Because we are connected to pin 13 but not to any pin which is written to with the name LED built in. Any answer? Let me see. Let me see in the chat. Anyone answering that? Okay, let me explain. Okay, I told you LED underscore built-in is AKA, or also known as built-in LED, of which if we replace this with pin 13, it will still work. But now you see, you'll have to replace it in all instances. So then start simulation, then hide. As you can see, our system is working. It's blinking very well, very well, very well. And this is the time the simulation is happening. Okay, let me answer the question for Patrick Wainaina, I think. So we have used pin 13. We can use any other pin. By the way, you can use any other pin, by the way. Like, for example, which pin do you want us to use? Which pin? Can you comment there below? Any pin from 0 to 13. Those are 14 digital pins. But okay, you should avoid using pin 0 and 1, but you can still use them. Maybe I'll tell you why, but we can still use. So which pin do you want us to use, or should I choose? Number 7 and number 2, we are going to use these two. So let's start with number 7. I usually love using pin number 7. So you just need to connect this way to pin number 7. Hey, very good in drawing. Okay, then we just need to enter to a code. But now our code will never work, will not work. I've started simulation, but it's not blinking. Why? Someone, why is it not blinking? Why? Let me see in the comment section. Why is it not blinking? Yet I'm connected. I've connected the resistor to, okay, the positive of the LED to pin number 7. Why is it not blinking? And I've run the code. The pin number is not changed. Changed. Okay, the pin number is not changed. We need to change the pin number. It's true. Let me see. There was another comment. Use of wrong address. Change to pin 7. Yes. Be nice to me. Okay, it's use of wrong address. We need to change to pin 7. It's either we change to pin 7 or we change back to pin 13. Actually, it will still work. You understand? So this means the hardware and the software must be in sync, like they must be in same. So what is easier? We can change the hardware or the code, but let's just change in the code. Pin number 7, put number 7. You see, these are a lot of work. Let's assume we have over 100 lines. We need to change pin number 7. You will be tired. So I'm going to show you another way we can do the same. We can achieve the same. So start simulation. You can see it's now blinking. It's now blinking. Okay, finally let's do another. The final one was pin number 2. We need to change this to pin number 2. Pin number 2. Sorry, let me just delete this one and start again. Start afresh. Pin number 2. Aesthetics. Okay, if I start simulation, it will not work, so we just need to change to pin number 2. Pin number 2, then start simulation, and boom, it's now blinking. Any question? Okay, finally I think we are almost ending. We have spent a lot, around 2 hours. Okay, so instead of just changing every other field whereby number 2 is appearing, we can use variables. So we are going to say in int led. We can give it any name, so we have the binomial nomenclature of naming leds, okay, variables in Arduino also as in other programming languages. So we are going to assign to, like right now we have assigned to pin number 2, then semicolon. So we are just going to replace this with led, this with led, and Arduino is case sensitive, so if you have used a lowercase, you have to use lowercase all through. So in case we need to change from pin number 2 to pin number, let's say another pin like number 5, you just need to change only one field, because this field will be equated to led. Okay, you understand now? Is there any question or link to WhatsApp group? Let me do that. So because that is a privacy, let me just okay, let me open the WhatsApp. I think I shared the link. Where did I share the link? Sorry. Oh, sorry. It's in this is it is in the presentation. Okay, let me look for the link. Sorry. Okay, it's in the last one. Okay, these are the links. Let me just copy them. Okay, if you want to join the WhatsApp group, okay, this is my own WhatsApp group, but we have ALX WhatsApp group also. Is there a way I can copy? Let me just copy, and this is the link to my channel, my TikTok channel. Let me just copy all of these. Thank you. Oh, you are not seeing. Sorry, sorry for that. I think you are not seeing that. So I think you can join even this is this is my WhatsApp group, and this is the ALX WhatsApp group, and also you can learn more about ALX, and also you can join ALX also, and maybe pursue a course, and join our robotics club. This is my TikTok account, whereby I usually post my oh, sorry, you are not seeing even. Sorry. Sorry for that. Okay, let's continue. I think we can continue. Any question? It's now time for Q&A, unless we have any question. Yes, you can unmute and continue. Proceed.
So thank you, Mr. Arduino, for this informative session. First, I'm a big
You're welcome.
and I'm glad to be here. So I have two questions. One, I'll refer back the question you had for us, whether you need to learn C++ or C to start prototyping in Arduino. Then the other question concerns, let's say you want to connect maybe a lot of outputs to the same ground. Like, how do you do? Let's say you have like five outputs that you want to connect to board. Do you use the same ground, or what do you do? Thank you.
So let me show you. Okay, let me start with this one for connecting. Okay, as you can see in Arduino, how do I move this one now? Oh, so in Arduino Uno specifically, we only have 1, 2, and 3 grounds. Okay, so let's assume we have like we are building a LED chaser, LED chaser, like with more than even more than three. So how do we approach it? Let's say we have 10 components or 10 LEDs. So now there is whereby we need to understand about this thing called breadboard. Now this is another issue. It's not that simple for you to master it, but it will depend with the how fast do you understand. Okay, just a minute. Let me just move these ones. Let me just delete and undo. Okay, let me take the breadboard. So what is a breadboard? A breadboard is a prototyping board which is used by makers. Like for example, let's assume okay, instead of building your solution like blinking LED, it's very simple. You cannot sell a project of blinking LED, you see. So like maybe you are testing your knowledge, you just need to plug in the LED. Like let me show you. LED, this one, just need to plug in the LED to the breadboard, and when you are done you just need to detach the LED. Okay, I think my time is not on the time is not on my side, but let's okay, let me just explain. You just need to to just need to expand the ground from one ground, then you connect to this one. As you can see my cursor, you can see the green line. That means all these are now grounds. All these are now grounds. All these are now have now become grounds. You see, now we can tap from this one, from any of these, like this one, and then maybe okay, let me just do this and do. Let's assume now we have another multiple LEDs like this one. We can now attach them from these grounds. You see this one, that will become one ground, another one. You can attach as many as these grounds. Also you can even expand from this one. Now you see, sorry, now you see you can also expand it to these. I think now you can understand. Okay, let me answer the second question. The second question was, which programming language do you need to learn? You just need to learn, you can learn one. C and C++, they are related. Actually, they are sisters, but okay, they made C, then they added some classes OOP, and they called the new programming language C++. So for me, I learned C++, which is simple and like C, and it's more advanced. So yes, as you know, plus plus is increment. For those who have a basic understanding. Okay, Samuel, do we include the minus sign in the pins that we have negative, e.g.? Okay, oh, no, you don't. Those are just markings, they are PWM. So let's say you are controlling the speed of motor. You see, for just a minute. You see, for if you are controlling like speed of motor, you see, if you connect it to pin number 3, it will work because it will give us somehow analog value. But if you connect to pin number 4, any other pin which is not PWM, it will not work, because those pin can only give 1 or 0. Yes. Any other question, because I think I need to end. Any question? So make sure you join those groups. We are going to send the materials there, maybe if you request, and all the communication will happen in that through those groups. Also, we have a physical event, like I think last month or this month we had one, a physical event which happened at the piano in Westlands. So our physical robotics event will happen on 30th of this month, actually, November, of which we are planning to be hosting around 2 events, physical ones in a month, and 2 virtual events like this one. This is the first one. Tomorrow we have second one. So you can join those groups. We are going to be communicating through those groups. Any other question? Thank you guys for joining, and see you tomorrow. Tomorrow we are going to start a bit earlier at 8, maybe 8 exactly. And also what else? Yeah, we are going to build some more serious projects, like maybe interact with some sensors. What else do you want us to build? Do you have any idea? Yes. Yes, you can comment. You can proceed. Who was that? Oh, it was not. It's a comment. Oh, gazebo simulation. Which one is that? You in this field you cannot be master of everything. You usually learn. Like for me, I am learning daily. So I think okay. Any comments? Any comments? Kindly, you can, any comments, any other business, you can chat there. You can type there. Anything else? Okay, I don't know if we have a good session. Okay, as we continue, Justin, are you in the call? Maybe if you are in the call, you can unmute and maybe brief us about ALX Robotics Club and maybe what you expect if you are in the call. Okay, thank you. Amazing sessions, good sessions. Oh, karibu sana. Now make sure you follow pale TikTok, you are going to learn more. You're going to learn more. These vitu, they are open source. I told you. Let me stop recording.